We're going to look at ways of writing numbers in standard form and ordinary form and converting from one to the other. My first bit of advice would be check with your colleagues in maths departments to find out what their preferred method is. So we are going to look at a method many of us have used many times, moving the decimal point, which is mathematically not necessarily a good thing. And we're then going to look at a more mathematically sound approach. However, if your maths department don't subscribe to one of those methods, please stick with the one that they do use so as to avoid confusion with students. So what we're going to do it through examples, and I'm going to look at converting the top two numbers to standard form by both hopping a decimal point along and also using another method, which I call the grid method, and then converting the numbers at the bottom to ordinary form, again using both a decimal point hopping method and the grid method. So let's have a look at all of these. If we start with the decimal point method, here we have the numbers. So the first complication, of course, if you want to convert this to standard form, is placing a decimal point. So the first almost contrived act is to put in a decimal point. And then the idea of jumping decimal points is you count the number of times you have to hop until you get one digit, which is either 1 up to 9, and then the decimal point. So we've done 1, 2, 3, 4, 5 moves. So that gives us, in standard form, 5.68054 times 10 to the 5. Now, decimal points don't actually hop. So a slightly more rigorous way of doing it would be this method. So what I've got here is a grid, and over the top of that, I've placed a piece of acetate. Now, I've also labelled up columns in ones, tens, hundreds, thousands, and so on, and tenths, hundredths, thousandths, and so on. Notice for those of us who have been around maybe a bit longer, I've put an O there rather than a U. Ones is now what's used rather than units. So let's write in the number and see how we use a grid. So I'm going to write the number in backwards just so that I ensure that all the digits are in the right place. So that was the number we've just converted. Then the idea is simply this: you count the number of places you have to move that to ensure that the mantissa is that number between 1 and 9.999, which sits in front of the 10 to the something or other. So 1 move, 2, 3, 4, 5, and because of that, we write times 10 to the 5. So let's just move on. I'm sorry, I'm having to adjust the exposure as the sun comes in and out. So I'll just delete that, delete it, rub it out. And let's go to the next. What I did want to show you, somebody asked me, what do you do if you don't have acetates? Acetates used to be around all the time years and years ago, but that's not necessarily the case anymore. So what I would do is just get a grid. I would get some squared paper, 1-2 centimeters squared will do fine. And do the same thing, but rather than doing it on an acetate, now what we do is we do it physically. And actually, this might be a very powerful method to use. So there's the number. So now let's move it one place, 8054. Let's move it another place. Notice the decimal point doesn't move, does it? 568. 054, still going. And then lo and behold, 8, 0, 5, 4. How many moves have we done? 1, 2, 3, 4, 5. And so that's times 10 to the 5. So that's worked quite nicely, hasn't it? So that's what to do with larger numbers. Let's have a quick look at smaller numbers. So at least this time, when converting this to standard form, we don't have to worry so much about adding a decimal point because there's already the decimal point there. But the hopping method would have us go 1, 2, 3. Now, because it's a number whose magnitude is less than 1, then the exponent is going to be negative. So that will give us 9.71 times 10 to the minus 3. Let's have a look at how we would do that on a grid. So on a grid, if we write that number in, we have 0.00971. And again, it's just about counting moves. So holding the acetate and moving it along. 1, 2, 3. 3 moves to get us 9 point something. So that gives us times 10 to the minus 3. Again, if you lack acetate or you want students to be able to do this at home and maybe in exams as well, then again, we can actually use just a grid on a piece of paper. So I need to put the point there, 0.00971, keeping the decimal point, and then start shifting things. So that's going to move up, and then we move it along again. I'm just checking, sorry, that's 1, and then one more move, 0.00971. 1, 2, 3 moves times 10 to the minus 3. So that allows us then to convert numbers in ordinary form to standard form. But what about moving in the other direction? What about undoing standard form? Well, actually, we do only have to do this backwards. So here we have 7.04 times 10 to the 4, and we want to convert that to ordinary form. The first thing to do, just write out this bit, that's called the mantissa, and stick a load of zeros after it. This is the decimal hopping way. So this tells us to hop 4 decimal places to the right. 1, 2, 3, 4. And that would then give us 70400 as the number in ordinary form. Now, yes, it's quick, it's convenient, but I question if it's mathematically correct. Let's see if we can do that on a grid. So I'll just rub out the previous question. And the number that we had was 7.04. So 7.04. Now, again, we've got to put in more zeros and put plenty in. I'll put in loads there. The 10 to the 4, just popping that up. In fact, let's leave that underneath. The 10 to the 4 tells me to move the digits by 4 steps. 1, 2, 3, 4. There it is. 70400. Now, again, what do we do if we don't have an acetate? Well, we can do the same thing as we did before, just actually use a grid. So I'm sticking on all the zeros, and it's telling me to do this 4 times. 40000, 704.0000. That's 2 moves. 704.000. 1, 2, 3 moves. 4th move coming up. There we go. Ordinary form. So we've just got one more to look at, and then we are finished. So the final question to look at is, let's have a negative exponent. And what do we do with that? Now, this is what's useful to point out to your students is when we've got powers of like -2, these are smaller numbers. So we expect this thing to get smaller. So that's telling us where we need to add in the extra zeros. This time, let's pop some extra zeros at the front. Now, the decimal hopping method would tell us now to hop this decimal point 2 places to the left. So let's do that. 1, 2, and that will give us 0. So there will be the new decimal point, 0.01629. Again, as I said earlier, it's convenient, and if that's the method that your maths department use in school, then go ahead. It's more important, I would argue, at this point, not to confuse students. So let's see how we can do that with a grid. So there's our grid. Let us write in the mantissa. That's, remember, the number at the front of the exponent. And let's also pop in those extra zeros that we're going to have to use. Now, I've popped 3 of them in. We may not need all of those. And now let's start moving. Now, this was, if you recall, times 10 to the -2. We know the number is going to get smaller. I know it's still the same size, but I think you understand what I mean. So we're going to do 2 moves. 1, 2. And there it is. Let's get rid of that 10 to the -2 now. And there we have it, 0. In fact, I can get rid of that as well, 0.01629. And finally, if you haven't got acetates, let's just do that on a piece of gridded paper. So our number was 1.629. We're going to add some zeros in as well. We'll pop 3 in. This time, let's keep the decimal points there. We're going to move it to, sorry, things have just got quite bright. This time we're going to move the digits that way. So we're going to have 1629, 0, 0, 0, because don't forget that was times 10 to the -2. So there's our first move, and then our second move, 0, 0, 0, 1, 6. I do apologize, I've missed a 2 there. 2, 9, 1, 6, 2, 9, and there we have it. So hopefully you'll find that useful, and please get in touch with me if you would like more information.